In the second rate of change video, we're going to talk about instantaneous rate of change as opposed to the average rate of change that we saw in the previous video. We're going to start with the same setup. We're going to have a position function. It's going to be a function of time. S of t is equal to negative 16.1 t squared plus initial velocity, that's v sub 0 times t, plus initial position. Our object is once again being thrown downward from the top of a 1,000-foot building. The initial velocity is 10 feet per second. And again, it's downward, so it'll be negative. So still, same as the last time, our position function will be negative 16.1 t squared minus 10t plus 1,000. Now, to find a velocity function, it turns out that velocity is a rate of change of position with respect to time. So instantaneous velocity is a derivative of an instantaneous position function, if you will, and that's what S of t is. S of t tells us a position at any moment in time t. So S prime of t is going to be equal to v of t, which in this case is going to be equal to negative 32.2 t minus 10. And that function will tell us the actual instantaneous velocity at any moment in time. This is kind of like what your speedometer does when you're driving your car. It tells you what your speed is at any given moment that you look at it, and it changes a lot. That's different from the average rate of change, which says that, for instance, you drove 60 miles, it took you exactly 1 hour, so your speed was 60 miles per hour. It's unlikely that you drove at exactly 60 miles per hour for that whole time, but that is your average. This function here gives us instantaneous, that is, that velocity at any given moment in time. So let's take a look at the second part here, where we're asked to come up with, for instance, v of 2. Well, we're going to plug 2 in. So we're going to end up in this case with negative 32.2 times 2 minus 10. And that'll give me negative 74.4 feet per second. It's going to be exactly the same units as the initial velocity, feet per second, since these are velocities. To find the velocity at 3 seconds, we're going to take negative 32.2, we're going to multiply it by 3, and we'll also subtract 10, and we'll find out that that is negative 106.6 feet per second. Pick any other value of time in between 2 and 3, and you'll get values in between negative 74.4 feet per second and negative 106.6 feet per second. So these again are instantaneous velocities exactly at that moment. These are not true at any other moment in time. This is not an average over some period of time. They're good only at those moments of time. And this is an important thing for you to understand, the difference between this idea of average velocity, average rates of change, and instantaneous rates of change, because that's what calculus really allows us to do. Actually, one of many things that calculus allows us to do is take a look at what happens in the moment, exactly at some point of time. We don't have to worry about trying to come up with averages. We don't have to worry about trying to come up with averages over very small time periods to approximate instantaneous things. We use the idea of a derivative, and it gives us something instantaneous exactly at some moment in time. And that's a really powerful concept.